This problem looks at Facebook users as a function of the number of months since August 2008. So off to the side here, I am going to identify my variables. I know that my output is going to be measured in months. I also know that my output is going to be measured in the number of users, which is in millions. So we'll just say that this is measured by millions of users. Okay, well what I'll do also is, because I know I'm working with derivatives here, I'm going to identify the output units of my derivative function. Now, recalling that the derivative is a slope generating function, it spits out slopes based on what month you feed it. Well, it's a rate of change in terms of change in output over change in input. So our output in this situation is millions of users, and the input is months. So this is a rate of change and will tell us for a given month what's happening to Facebook users in terms of, is it increasing by a certain million number of users per month, or is it increasing at that moment by a certain number of users per month. So now I'm going to go on my way to answering some of these questions. So f of 37 requires me to look at the original function, not the derivative, and I have in my calculator this equation typed in, 0.1x squared plus 15.1x plus 94.9. I will come over to my table and I will simply input 37. A couple of different ways you can do this. This is just one. 37 for an input generates an output of 790.5. Okay, well, we already said that the output is in millions of users, so you have that many million users in this particular month. Well, since this is months since August 2008, question is, what is 37 months since August 2008? So I'll just say August 2008 would be 0, 12 would be August 2009, 36 would be August, would be 2 years later, 2011, and so that means 37 would be September of 2011. So in September of 2011, this model predicts that there were 790.5 million users. In part B, we want to find the derivative function. We already identified what it outputs. It outputs the rate of change of users per month. To find the function, we're going to use the power rule. So we're going to drop the power, multiply by 0.1, we get 0.2, subtract 1 from the exponent, so we get 0.2m to the first. 15.1m, its derivative will just be 15.1, and the derivative of the constant is 0, so that is not necessary to copy down. In part C, we want to identify or find a few different rates of change. So we'll find f prime of 0 first, and to make this convenient, I'll just go ahead and type in 0.2x plus 15.1 into my y equals, and then I will come over to my table, and now I can really quickly generate these. Just do 0, 24, and 36, and so those are the three slopes I'm going to want to find. So 0 gives me an output of 15.1, and now this is the derivative, so its output is, it's in millions of users per month. So that's the increase. That's what's basically happening in August 2008. The number of users is going up by 15.1 million per month. In the 24th month, which is August 2010, the number of users is still going up, but it's now increasing at a faster rate. It's now increasing by 19.9 million users per month. So not only is it increasing, but it's increasing at a faster rate. And excuse me, but this should be f prime of 24. And then finally, f prime of 36 is, well, what happened in August 2011. And in August 2011, the rate of change was 22.3 million users per month. All right, well, beautiful. So it looks like, again, the number of Facebook users is increasing at an increasing rate, which only tells us that as time passes, yes, the users is going up, but it's going up faster and faster and faster as the number of months pass by. So this is kind of an image that we can deduce from what we're seeing here, because it's growing and it's growing at a faster rate. And so here would be f of m, and here would be m. So that's what the derivative tells us. Next we want to graph the derivative, and we want to figure out what this tells us about Facebook. So I'm just going to go ahead and make sure that my zoom is set to standard. Now you can see I can't see the equation there yet because the vertical intercept for this function, this derivative function, is 15.1. Well, I could set my window, or I could just zoom out and probably will be able to see a pretty good picture of it. So there it is. And I see that the derivative function itself is linear. So what does that tell me? Well, on the input axis we still have months. So this is looking at months. However, the vertical axis is now looking at the growth rate. So what's happening as months pass by to the growth rate? We saw here that the growth rate itself is increasing, it's going up. And now we can see that the growth rate is increasing at a linear rate. So that's really what this tells us about Facebook, is that the users are increasing, but they're increasing at an increasing rate, at a constant increasing rate. So we can see that by going back to our derivative function. So this guy outputs slopes, right? This guy outputs slopes in terms of millions of users per month. Well, as m gets bigger, at first, at 0, we just have 15.1 is the output. But for every month we go up, the rate of change, the slope, gets 0.2 units bigger. So in month 1, that is September 2008, it's 0.2 plus 15.1. In month 2, it's 0.4 plus 15.1. And so we can see that our output of this function is actually growing at a linear rate. In f, we want to find and interpret f prime of m equals 20. So f prime of m equals 20. Now f prime of m is equal to 0.2 m plus 15.1. So what does it mean to have f prime of m equal to 20? Well, obviously I don't know what the month is, but I do know that the derivative output for whatever month I've input in, I want to be 20. So it literally says, let f prime of m equal 20. So here's f prime of m. I'm going to replace it with 20, and I'm going to solve for what's left. Okay, well, what am I trying to figure out? Since this is the slope, I want to figure out when is the slope equal to 20 million users per month. So this is a pretty quick solve. I'll subtract 15.1, and that will give me over here 4.9 equals 0.2 m, and then I'll divide by 0.2, and I'll divide by 0.2, and I get 4.9 divided by 0.2, which is a syntax error. Oh, extra decimal place there. And I see that that's 24.5. So m is equal to 24.5. So this means that in about midway through August, because that's 24, but it's 2 years after August 2008, so midway through August 2010, Facebook is growing by 24.5 million users per month. So what does that tell me? Well, if I actually knew the number of users in 24.5, so I'm gonna try to figure out how many users were there in that particular month, just to demonstrate a point. So 0.1, 24.5 squared. All I'm trying to do is figure out how many users there were in that month, midway through August of 2010. So I'm just plugging in 24.5 plus 94.9. Oops. And I get 524.9 million users. So in m equals 24.5, the output, so here's 24.5, the output for that particular point would be what we just found, 524.875. So this is a million users, and this is the month. Okay, well, so here's kind of what the curve looks like, and now I know that at that moment, the instantaneous rate of change is equal to 20. So this guy has a slope of 20 million users per month. So that allows me to be able to basically figure out, make an estimate of what's going to happen the following month. So if there are 524.9 users in 24.5, 524.9 million users, so that means in 25.5, 1 month later, I should grow by 20 million users. So I should have not 524, but 544.9 million users. That is just an estimate based on an instantaneous rate of change, but that's really what I can do with it.